So let's go with 468. We're going to move this, turn this into radians, right? And so if I take the degrees, 468, what do I multiply it by to get to radians?
Pi over 180.
Pi over 180. Okay? And so I start to think of like what goes into the top and bottom. What can I pull out and get rid of to get it smaller and smaller and smaller, right? So I noticed right away that 2 goes into them, right? So let's just take a 2 out to begin with, right? So if I take a 2 out of here, then that's 2, 3, 4 pi over 90, right? And I'm like, well, I could take another 2 out. Okay? So that would be 1 and 1 with 1, and then 7. Woo, that's a nasty number. Over what?
45.
45. Wow. Doesn't look like much goes into that. But wait a minute. 7 plus 1 plus 1 is 9, right? And 9 is divisible by 3. And 4 plus 5 is 9, which is also divisible by 3. So I know that 3 goes into both of these. Doesn't look like 3 goes into 117, does it?
No, it does.
But it does.
That's
If
90
you
and
think
27.
about it,
So-
3 times 40 goes into 3 times 40 equals 120, and if you subtract by 3, then you automatically get it. So it's actually in reality 39.
There you go. All right, so how many times does 3 go into 11? 9?
39.
39?
It's just 90 and 27.
All right, so 3 goes into 11 3 times with 2 left over, right? And 3 goes into 27 9 times, so that's your 39. Pi over 15. Oh, well, 3 goes into both of those, right? How many times?
13 over 5.
1, 13 over 5. Holy cats. We got to our 13 pi over 5. And that's our radians, right? Fun times. So that's 4 points right there. Cool. That was a good way to get there. I mean, yes, could we have just divided it by 4 and then 9? Or hey, how about 4 times 9, right? Yes, you could have. Okay? But if you didn't see it, that's why upside down division works really well. It will get you there. Fast or slow, it will still get you there. Okay? All right, so what's next? I need to graph this. How do I graph this? Well, I can graph radians really easy. But how would I graph the degrees? Is that just as easy? And yes, it is. Because think 468, that's 360 right there, right? So 360 from 468 leaves me how much?
108.
108. So then that means I go to 90, which leaves me 18 more, right? So I'm just coming a sliver more. There's 18 right there, right? But we don't care about the 18, do we? We only care about it to graph the angle. So now I graph the angle, and the angle is a 468 degree angle, or 13 pi over 5. So why is it 13 pi over 5? And it's because this thing's broken into 5 pieces. There's 1 piece. 2, 3 pieces. 4, 5 pieces. And each piece is how much? 36 degrees. Okay? And so how many pieces of 36 are there to get me up to that radians? 1, 1, 2. So my reference angle is 2 pi over 5, right? My reference angle is 2 pi over 5, or we're thinking of 90 minus 90 minus 18, which is 72. See how that works? With the radians versus degrees, right? Pretty cool? No? Yeah? Kind of? Not as cool as the 420, I guess. But almost as cool. Almost. Okay. So then, so then we got the 2 pi over 5, right? To get to there from here, that was 3 pi over 5, right? Okay. So we know our reference angle. Oh. What do we need now? The coterminals, right? So think about that. We got this degree that's up here. Well, it's really like this, right? And there's 5 of those pieces, right? So if I wanted to get to here positively, it would be how many pieces? 1, 2, 3 pi over
4.
how much?
5.
5. Or 108, right? And that would be your positive coterminal. Four points. What's my negative coterminal?
Let's take a look at that.
Well, this would be 5 out of 5.
That would be 7.
Nice. Paul? Is that-
Wait, 5.
Negative 7 over 5.
Negative 7 over 5.
Wait. I thought it was -9 or 5.
Why would it be 9?
Well, okay, so like looking at my graph, like you go around this way
Right.
once, that's 5.
That's 5.
And then counting up to just 6, 7.
6, 7.
Oh, I started from the wrong side.
Okay, that's cool. But you get it now, right?
Yeah.
Cool. All right, and then how many degrees is that? That's 180 plus your reference angle, which is 72. So 180 plus 72 puts us at
252.
1 or 252. My bad, 252. Right? Okay, so that would equal our, negative 252. That would be our negative coterminal, right? Which is another 4 points. Okay? All right, so we have this. We have 4 points for our reference angle. We have 4 points for our graph. We have 4 points for the conversion. So that's 1, 2, 3, 4, 5. We need one more. We need our, right, Rocco? Our coordinate. So what's our coordinate? That's the hard part, because that's why we're here, right? To figure out what's the coordinate here.
Yeah, you can basically put it as cosine. You can basically put cosine in sine.
Right. Remember, this and this, right? What angle is this? Rocco, what angle is this? It is acute, you're right. It's like me, very acute. That's what I'm always told. You're very acute. 72. 72. It's the reference angle, right? 72 degrees. So remember, our x and y. What's our x?
Cosine of 72.
Cosine. Why is it cosine? Because it's the adjacent, right? Over the hypotenuse. The adjacent of the angle, right? And the adjacent of the angle is the adjacent of 72 degrees, right? And then the height is
1 over
sine, right, of 72 degrees. But we could also write this as what? Sine and cosine of what?
108.
Yes.
2 pi by
Not 108.
18.
2 pi by 5.
2 pi over 5. 2 pi over 5. The other way to write 72 degrees. Right? 2 pi over 5. Question? Ah! Yes! Now we come up to the whole aspect of, wait a minute, that's if they were both positive. Are they both positive?
No, they're both negative.
No, the cosine or the x is negative, right? Now if it were down here, the sine would be negative also, right? But because it's up here, the cosine is negative, right? But the sine is positive. Does that make sense? Okay, and that's how you figure out whether or not you got a sine, whether you have a negative or a positive degree. Okay? Or the coordinate, I should say. Negative or positive coordinate. Paul.
Alright, so do you have to like solve the cosine and sine, or can you just leave it at negative cosine?
No, I want you to leave it like this.
Okay, cool.
Yeah, because we don't have a calculator, right?
Mm-hmm.
So, yeah, I'm just having you leave it like this, and that way I can see that you understand it. And if you want to put it in the calculator and solve it afterwards, that's cool too. So that I know that you know how to do that also, right? So on the calculator quiz, you're going to show me this and then show me the money with what the actual degree is. Does that make sense? And then you'll plug it in and it'll give you like 0.9. And why is it 0.9, by the way? Why is it always giving you 0.9 and 0.1 and all that stuff? Why? Because the hypotenuse is 1. And so the sides are less than 1, right? Because if they were 1, then what happens is they collapse, right? And that's what happens when we go straight up and down or straight left and right. Yeah? All right, good job. Any other questions before we stop?